Hi there, in this video clip today I want to look at reversible reactions and equilibrium. What is a reversible reaction? An example is simply a reaction in which the reactants, would you believe it? The reactants A and B, or that could just be A or B. That's the sign for a reversible reaction. Gives me C plus D, i.e. reactants give products and products give reactants. So for an actual example, if I took ammonium chloride and heat it, it decomposes into ammonia, NH3 and hydrogen chloride. In fact, what happens is I heat that solid powder and it gives me a vapor or a gas. It gives me that gas, ammonia gas, and hydrogen chloride gas. And you get a white smoke formed when that is heated. The white smoke, which contains ammonia and hydrogen chloride, combines there together, so it forms the reactant. When the forward rate of reaction is equal to the reverse rate, the reaction is said to be at equilibrium, but I'll be talking about that quite soon. Let's look at another reversible reaction. Good old copper sulfate, CuSO4. In the crystalline form, it contains 5 molecules of water of crystallization. I heat it up. By the way, that's blue. I heat it up and it turns white to white anhydrous copper sulfate, plus it liberates 5 molecules of water of crystallization. Translating that into normal English, I heat hydrated or copper sulfate crystals, steam comes off and it forms anhydrous copper sulfate, and that recombines again to form the initial reactants, blue copper sulfate crystals. I said that a system at equilibrium is when the forward rate is equal to the reverse rate. If you've got a closed system and it's at equilibrium, the forward rate is equal to the reverse rate. A thing which I want to state now is, if I had a reaction A, and that could be A plus B plus C. Okay, let's make it A plus B, giving you C plus D. If that forward reaction is exothermic is giving out heat, guess what the reverse reaction would be? That would be endothermic. And if that forward rate is endothermic, giving out heat, it gets cooler. The other reverse reaction is exothermic. There's a guy called Le Chatelier, and Le Chatelier has a principle which applied to reactions at equilibrium. He simply said, if you change the reaction conditions or the product conditions, an equal and opposite effect takes place. So let me just explain that again. A plus B going to give you C plus D. If I change the concentration, hello, can't spell, concentration of the reactants, if I change the temperature of the reactants, temperature, can't spell, temperature of the reactants, and if it applied to a gas, if I change the pressure of the reactants, it will give you an equal and opposite change in the concentration of the products. Concentration, temperature, change the temperature, an equal and opposite effect affects the products, and the pressure with a gas. If I change the pressure, I change the pressure of the reactants in the gas, there will be an equal and opposite change in the pressure. For example, let's look at two gas reactions, nitrogen reacting with hydrogen to produce ammonia. And another example is if I took nitrogen dioxide, it forms N2O4. So I'm going there from 1 volume, I'm going from 4 volumes to 2 volumes, and here I'm going from 2 volumes to 1 volume. So what can you tell me about that? If I increase the pressure of this, there's an equal and opposite change in that. So in fact you can see that if I increase that pressure, the particles of the gas get closer together, so it reacts quicker. But at the same time, the forward rate increases, so guess what happens to the back rate? It increases as well. So a change in these would be favoured by an increase in pressure, those two reactions. And the final change is if I took something like the endothermic reaction. I've got an endothermic reaction, that's endothermic reaction. As I increase the temperature of an endothermic reaction, it goes back that way. And if it was an exothermic reaction, moving it to the right, for the products it moves back. And it does that until the forward rate of reaction is equal to the reverse rate of the reaction. So that's it, Le Chatelier's principle for a reaction. If I do anything to the reactants, this equal and opposite thing occurs with the products. If it's exothermic reaction going that way, moving it that way, it moves back that way. It's an exothermic. And when the rate of an exothermic reaction is equal to the rate of endothermic reaction, the system's at equilibrium. If the concentrations of the reactants is equal to that of the products, and it's moving backwards and forwards, it's at equilibrium. And if the pressure of the reactants is the same as the pressure of the products, the system's at equilibrium. That's it, folks.